Technological wonders, apogee of engineering, the planes from the future that came off the pages of science fiction novels. These airliners were supposed to be a jump into a new era, but the scale of this jump could ultimately be compared only with the scale of its downfall. Hello aviation fans, Sky here, and the time has come to dive into the history of three airliners, the names of which are now the names of the fallen gods, relics of an era that never came to be. The first of them will be the one that started it all, or at least it tried. The history of post-war civilian aviation, especially the 1950s, was full of events. In the first years after the World War II, it became clear that piston airplanes had reached their limits, and at this time, the rise of a new technology began, which was destined to conquer the sky. The military pilots met the first jet airplanes that quickly proved their almost absolute superiority over the old machines. After the military jet aircraft, it was time for the civilian planes. In 1949, the first flight of the de Havilland Comet was made. The first commercial jet airliner in history was a real revolution. Despite the many problems and accidents, it proved that the future belongs to its breed. And of course, its most important trump card was speed. Over the next few years, jet airliners appeared in other countries. Tu-104, Boeing 707, DC-8, Caravelle, and so on. New planes were replacing the old ones, becoming more reliable, more comfortable, and faster. The main trend was still the speed. Aircraft manufacturers tried to bring those indicators to a maximum, and if the first airliners flew at speeds of around 500 miles per hour, the next generation went beyond 550 miles per hour. And some planes were already getting close to the Mach of 620 miles, or nearly 1000 kilometers per hour. It was a matter of prestige for manufacturers and airlines, and from an economic standpoint, high speeds meant more flights on fewer aircraft. This concept at that time was the main competitor of the concept of increased capacity, which later gave birth to the wide-body airliners. But the speed of around 500 miles per hour was the limit of what classic jets could afford. In order to cross that line, it would take a revolution. October 14, 1947. The Bell X-1 experimental aircraft, during a test flight, reached the speed of Mach 1.06, overcoming the sound barrier and opening the door into the supersonic era. In the early 1950s, the first serious supersonic F-100 Super Sabre, MiG-19, and Dassault Super Mystère fighter jets conquered the sky. The technology and the entire industry were developing at a fantastic pace, and supersonic became an option not only for light fighters, but for more heavy predators as well. In the late 1950s, the world saw the first representatives of this breed, the B-52 Hustler and Tupolev-22 supersonic bombers. By this time, a new topic had become obvious. Since the technology allows the creation of supersonic bombers, then perhaps it can already open a door for supersonic commercial aviation. Having the same speed, such airliners will be able to deliver passengers much faster than usual. This was enough to interest all industry leaders. The first research of a supersonic passenger plane began in the early 1950s. While the Americans and the Soviets were busy inventing new ways to destroy each other, the British created a special committee to work out the prospects of creating the first supersonic civilian aircraft. Nobody had any illusions. The creation of such an aircraft required to overcome very serious challenges. Yes, supersonic airplanes were already there, but they were terribly uneconomical, dependent of the infrastructure, and they had a flying resource of a butterfly. These facts were acceptable in a military aviation, but the supersonic flight on a civilian plane meant that in order to provide the required passenger and fuel capacity, the plane would have to be made huge, and to accelerate all this to required speeds, it would take incredibly powerful engines. And even if this plane was created, its flight at low speeds would be almost impossible, which means that takeoff and landing speeds would be outrageous. There was simply no runways this long. The conclusion was obvious. The creation of such an aircraft is too complicated and impractical. However, in parallel with this work, active research continued in the field of supersonic aerodynamics. One of the major breakthroughs was the creation of a slender delta concept. This design made it possible to provide high speeds, enough lifting force, and, at the same time, sufficiently high reliability. it was quickly applied in military aviation. The B-58 and M-50 had a wing of this kind. Surveys also showed that the efficiency of this wing grows even more if you enlarge the area not by increasing the overall size, but by changing the shape, by stretching the wing along the fuselage. This scheme still provided good supersonic performance, but also allowed the aircraft to fly at lower speeds. Theoretically, an airplane with such a wing could already be created and used. In 1956, it was decided to test the new development in practice, which is why the Handley Page HP-115 Flying Lab was created. The plane did its job. It could support a controlled flight at speeds much lower than the fighter jets with the classic delta and swept wings. A recommendation was made to create two aircraft: a 150-seat plane for transatlantic flights, capable of flying at speeds of about Mach 2, and a little 100-seat plane for regional flights at a speed of about Mach 1.2. These machines were supposed to appear by 1970 and, as expected, become a new milestone in the aircraft industry. The British, who created the first jetliner, now wanted to create the first supersonic one. France at this time conducted its own research. In the late 1950s, on the basis of its own results, as well as due to the British experience, the development of a supersonic aircraft was launched according to the new wing scheme. After a series of tenders, the project was given to Saud Aviation. Their project, Super Caravel, was to become a 70-seat aircraft capable of flying at speeds of about Mach 2, up to 1600 nautical miles. Unlike the British, who decided to capture the market of large supersonic airliners, the French counted on a smaller plane, knowing that the transatlantic would be cramped. Apart from the British, the Americans also claimed it. However, over time, the design teams on both sides of the English Channel realized that they could not develop such a plane without partnership. The British lacked resources, and the French lacked technologies, especially in the engines department. Meanwhile, after the start of negotiations, it turned out that both of them are creating practically the same plane. They argued only about the size and range. London wanted to create a 150-seat long-range airliner, and Paris a 70-seat regional aircraft. They wanted to solve the issue through unification and worked on two options: a 4-engine aircraft with a shorter fuselage and a 6-engine plane with an extended one. The only thing that needed reconstruction was the wing. The agreement of cooperation between the countries on the creation of the airliner was signed at the end of 1962. Then the project was officially announced. The word Concorde, which has the same meaning in both English and French, was chosen as a name, although there had been disputes. The fact is that in English this word is written Concorde, and in French Concorde. Having agreed on all the issues, politicians were arguing about the letter E at the end for a long time. Market research showed that the new consortium would be able to deliver about 350 aircraft before 1980, given that the American competitor was well behind, and the Soviet one did not have claims for the Concorde's market at all. Despite the fact that Concorde was perceived as a revolution in the aviation industry and a future icon of the aircraft manufacturing, it was rather difficult to find customers for it. At this stage, it was decided to abandon the little version of the aircraft. There was no demand for it at all. The consortium focused on the creation and promotion of the large version, with a capacity of 100 to 120 passengers, flying at a distance of about 3,200 nautical miles, or 6,000 kilometers. Pressure on the aircraft, and in general on the concept of supersonic passenger transportation, increased even more after the publication of the results of supersonic airplanes test flights over the settlements near the city of Oklahoma, USA, in 1964. As part of the test, the XB-70 Valkyrie bomber prototype made several supersonic flights over the city. As it turned out, the sonic boom brought serious inconvenience to the population, broke windows and destroyed structures. The altitude did not solve the problem. The plane was flying at a ceiling of 77,000 feet, or 23 kilometers, well above the flying altitudes of civilian supersonic aircraft. This caused debates among experts and politicians, which could potentially limit demand. Nevertheless, the consortium managed to form a portfolio of orders for 100 airplanes from 18 airlines, while BOAC, Air France, and Pan Am were to become the launch operators. So, what is Concorde? Concorde has an airframe made according to the tailless design. with a complex-shaped delta wing, the so-called ogival wing. Thanks to this wing, the standard landing speed of Concorde was nearly 170 miles per hour, or 270 kilometers per hour, and the required runway length at full load 12,000 feet, or 3.6 kilometers. A lot, but already acceptable. Supersonic flights led to quite significant temperature swings of the structure. 130 degrees Celsius were considered normal, and the length of the fuselage due to heating could grow by 1 feet and shrink back when cooled. In order for the aircraft to not overheat and collapse in such modes, a special aluminum alloy was developed for it, heat-resistant but lightweight enough. The fuselage of the aircraft in cross-section is not round. It has an oval shape with an extension in the area of passenger compartment. The maximum capacity of the cabin is 128 seats, but this is for the economy class, and considering the ticket prices, there was no economy in practice. The airliners received business class for 92 to 108 seats. The layout is standard for cabins of such widths, 4 seats in a row with a 2+2 scheme. According to today's business class standards, it looks pretty rough. But let's be honest, you don't buy the Concorde tickets for its seats. Among the features of the cabin, I can also note the presence of a large panel, showing the speed and altitude, as well as the hidden radiation dosimeters. At that time, among the aviation enthusiasts, there were fears that at such heights, people will be exposed to more radiation. For this reason, the dosimeters were installed, and in case of a radiation spike, the pilots were instructed to lower the speed and altitude. As practice had shown, the risks were exaggerated. The problem never arose. The question of what kind of power plant and in what configuration it should be installed in the aircraft was open since 1960. Moreover, entire scientific conferences were assembled in order to answer those questions. For a long time, engineers were wondering to install the engines inside the airframe or to place them in the engine nacelles. When they decided to put them in a nacelle, a new question arose. In pairs or separately. In addition, at first it wasn't clear how many engines should be there. Initially it was planned to put 6, but it turned out to be too much. In the end, the plane received 4 Rolls-Royce Snecma Olympus engines, a wide modification of the military version of the Olympus power plant, installed on British Avro Vulcan and BAC TSR-2 bombers. The engines were arranged in pairs in 2 nacelles installed under the wing. The power plant had many features, some of which were quite breakthrough. It received automatically adjustable air intakes and a complex electronic control system, the predecessor of the modern FEDEC. Naturally, the engines had afterburners. However, their significance was the fact that they had very high thrust without afterburning, and the maximum mode added only about 18% of thrust, 140 kilonewtons in normal mode, and 169 kilonewtons with the afterburners at maximum. It was used during takeoffs and to overcome the sound barrier. In the cruise flight, however, the aircraft managed to maintain supersonic speed of Mach 2 without the afterburners. Yes, just like the 5th generation jet fighters. This made it possible to maintain the average fuel consumption at about 22 tons per hour, which was an outstanding indicator for a supersonic aircraft of this size and mass, although it seemed a horror for a subsonic aircraft. In fact, according to statistics, the liner was spending about 2% of its fuel while still taxiing around the airfield. To reduce the landing distance, the power plant received the reversed mechanisms capable of creating reverse thrust up to 40% of the norm. Considering that the engines were the main source of the noise, engineers did their best to try and reduce it by installing many small additional elements. The reduction of the noise level inside the cabin was provided mainly due to the fact that the engine nacelles were placed under the wing away from the fuselage. And again, the afterburner turned off during the cruise flight was a big plus. The aircraft's fuel system was quite complex. Its feature was an additional functionality. The fuel could be pumped from tank to tank for balancing in different flight modes. In addition, it was used as a coolant to redistribute excess temperatures away from the heated internal elements. That's right, kerosene as a coolant. The aircraft had no auxiliary power unit. This simplified the design, made the plane a bit lighter, and its absence was actually not a problem, since Concordes themselves were very demanding of ground infrastructure, and the airports capable of receiving them automatically had the necessary ground equipment. The landing gear at first glance is usual, but due to the fact that during takeoff and landing the plane gains a sufficiently large angle of attack, in order to avoid touching the runways with its tail, it was equipped with a very high legs, about 3.5 meters. Therefore, surrounded by ordinary airliners, it looked like a heron on the long legs. Brakes on the landing gear received the first electronic control system, as well as cooled carbon discs. Because of the requirements to reduce drag of the aircraft, the nose section had the shape of a sharp cone. However, to ensure visual control by the crew, it was made droppable. The nose had several modes of operation, from completely straight for supersonic flights to 12.5 degrees down during takeoffs and landings. In the raised mode, the upper part was closed with additional glazing, providing visibility and, at the same time, the aerodynamic efficiency of the nose. The Concorde avionics at the time were very advanced. The mechanical control of the aircraft had an additional electronic duplication, which became, in fact, the forerunner of the fly-by-wire control systems. The airliner had the highest level of automation. Thanks to the very advanced avionics and the new cabin equipment, the crew was reduced to 3 people, and this is on one of the most complex planes of the time. The assembly of the first prototype began in 1965 at factories in Toulouse and Bristol. Concorde made its maiden flight at an airport in Toulouse on March 2, 1969, and for the first time on October 1st, it broke the sound barrier. In parallel, the British assembled prototype began to fly. Both aircraft were first presented at the Paris Air Show in the summer of 1969. By 1971, the aircraft began to carry out test and demonstration flights over long distances, including the flights to America, Middle East and Asia. And at the Paris Air Show in 1971, Concorde for the first time met its Soviet brother, the Tupolev 144. These airplanes were originally designed for the long-range flights, primarily on the Atlantic routes. And even though the first prototypes were fully capable of achieving this goal, it was still rather difficult for them and required special flight conditions. Nevertheless, the aircraft were very good, and later a number of adjustments improved the quality of the airframe, increased fuel capacity and engine efficiency. After the modernizations, the Concorde seemed like a total candy. While the standard flight from Paris to New York was taking about 8 hours, Concorde was reaching its destination in 3.5 hours. In addition, due to the high speed and altitude of about 60,000 feet or 18 kilometers, it did not need to coordinate its route with other flights. There were simply no other planes at such altitudes, except maybe the military. Nevertheless, flight demonstrations at the air shows played a cruel joke with the airplanes. Many potential operators, experts and ordinary people quickly noticed the problem of very noisy takeoffs and landings, sonic booms and environmental risks. In addition, the crash of the Tu-144 during the demonstration flight at the Paris Air Show in 1973 raised fears that the planes were unreliable, and this concerned not only the Soviet airliner, but also this class in general, which means Concorde too. All these factors greatly reduced the demand for the airliners, even before the start of their deliveries. These circumstances were a shock to many people from the camp of supersonic transport supporters. Back in the mid-1960s, it was thought that supersonic aviation would conquer the passenger traffic. Even Boeing, creating the Model 747, initially relied more on its cargo versions, thinking that the main passenger airliner would be the supersonic Model 2707. But then everything had changed. The restrictions on the operations and flights above the populated regions were not the only problem. In the 1970s, the energy crisis started, raising fuel prices. Supersonic airplanes were good, but their commercial operation was on the edge of zero profitability. At the same time, with an increase of the share of fuel in the cost of flights, the superiority of wide-body aircraft increased. The fuel consumption per passenger was almost 3 times higher than that of the Boeing 747, and with the advent of twin-engine wide-body airliners, this ratio for supersonic aircraft had gotten even worse. As a result, the sunset of the supersonic era of air travel began while it was still on its rise. The demand for Concorde fell, the Tu-144 developers faced a huge amount of problems, and in 1971 the Boeing 2707 project was closed completely. In fact, by 1976 the Concordes were being assembled just for two airlines, Air France and British Airways. They bought 9 planes. The consortium, having built 14 machines, could not find customers for the remaining 5 and actually offered them to the same operators for free, having received for them £1 and £1 respectively, with the commitment to operate these airliners. There were now 7 aircraft on each side of the English Channel. Commercial operation began in early 1976. Aircraft flew from London to Bahrain and from Paris to Dhaka. Flights to the United States faced problems from local politicians and public organizations' resistance, but by 1977 the Concordes began to fly to Washington and New York. Despite the presence of regular flights to different cities of North and South America and Asia, the routes from the 2 European capitals to New York had actually become the most popular. The airlines immediately faced huge operating costs. The problem was compensated, of course, by the very high prices for tickets. In fact, flights on Concorde became a unique experience and luxury for the rich. Traveling from New York to London and back could cost up to $10,000, many times more expensive than the business class of any other aircraft. However, the demand was found. Such flights were very popular despite the cost. Air France and British Airways positioned the Concordes as flagships of their parks. The best crews were selected for them, and the level of service was as high as it gets. The pilots were even showing certain arrogance in front of their colleagues, bragging how they looked down on the others lagging somewhere downstairs. In this case, given that the speed and height of their flights were much higher, these comments could be taken literally. In addition to regular flights, Concorde performed many special flights, promotional tours and charter flights to various cities around the world. Several times the planes were leased to Braniff International and Singapore Airlines, but they usually didn't stay there for long. Despite the popularity and important status of the aircraft, their commercial operation was very difficult and practically wasn't bringing any profit. In addition, with the passing years and the development of new, more and more efficient airliners, the Concordes had become completely uncompetitive by the beginning of the 21st century. The final blow came after the Air France plane crash in the year 2000. The Paris-New York airliner suffered damage during takeoff, caught fire and fell close to the airport. 109 people were killed aboard and 4 others in the building on which the plane crashed. The flights were suspended immediately. The aircraft underwent modernization in order to avoid such a tragedy from repeating itself. But even after all the issues were resolved, in 2002 and 2003 there were several more incidents that finally convinced the airlines that the time of Concorde had passed. In the spring of 2003, British Airways and Air France announced the end of operations. On November 26, 2003, the BA airliner took off from Heathrow and arrived to Bristol. Concordes had left the skies for good. The remaining airliners were transferred mainly to museums around the world. Can Concorde be considered a failure? Perhaps, though in this case it fell victim to the failure of the entire supersonic commercial traffic concept. Despite the technological revolution, it still did not solve a number of fundamental problems, which in fact have not been solved to this day. The plane had lost, but fought for a long time. Its Soviet competitor was making passenger flights for less than a year, and the American airliner never saw the sky at all. Can Concorde be considered a success? Well, the plane itself was not successful, of course. But if we dig deeper, we can see a huge mass of knowledge gained from its creation, and the breakthrough technologies successfully applied in future aircraft. And one more thing about the future. While creating this failed airliner, the Europeans brought cooperation in the industry to an unprecedented level. In a sense, we can assume that the Concorde consortium became the forerunner of what we now know as Airbus. So everything has its advantages and problems. For example, the video is coming to an end, but you can still give it a like and subscribe to the channel. Comment what you think about this marvel, and soon we will continue to the next one. Fast, though not supersonic flights, and soft landings to you.